Alright, hello everyone. This is Miss Evangelista, and this is video 4.1, Properties of Rational Functions. Our objective for this video is that students will be able to determine the horizontal and vertical asymptotes, x-intercepts, and y-intercepts of a rational function. Please make sure that you copy the title of this video in your notes, as well as the objective. So what exactly is a rational function? Well, hopefully you recall from Algebra 2 that a rational function is a quotient of polynomial functions. So anytime we take two polynomials, say n of x and d of x, and we have a quotient, or we divide them, there's a ratio of them, that is a rational function. Of course, the domain of a rational function is the set of real numbers for which the denominator is not 0, because otherwise our function would be undefined. Go ahead and pause the video, make sure that you copy some form of this definition. What does the graph of the parent rational function look like? Well, a parent function is, remember, the most basic, simplest form of any function. Well, the parent rational function is f of x equals 1 over x. Go ahead and type that into your calculator and see what it looks like. Feel free to pause the video as you need. Now that you have typed that into your calculator, you see that this is what our rational function looks like. Now, what are some things that you notice about this graph? Hopefully, you see that to the left here, the graph looks like it's getting closer and closer to that x-axis. In fact, it looks like the graph is actually touching the x-axis as x approaches negative infinity. Well, let's test that. Will y ever actually equal 0? Okay. Now, let's plug negative 12.5 into our function f of x. So 1 over negative 12.5. What y value will that give us? Negative 0.08. So yeah, it's really close to the x-axis, but doesn't actually equal it. Well, you might be asking yourself, what happens if we were to plug in an even smaller x value, say negative 100? Would our y value then equal 0? Well, then it would equal, if we plugged in negative 100 for x here, it would equal negative 0.01, negative 1/100. And what about negative 1 million? Well, it would be even a smaller number, but still does not equal 0. What do we call this? An asymptote. Okay, an asymptote is a straight line. The graph approaches, but does not actually cross. In this case, we have a horizontal asymptote, because it's a horizontal line that the graph gets really close to, but doesn't actually touch. So our equation for the horizontal asymptote is y equals 0. You have to write y equals because it is the equation of a line. Now, if we look at this graph, hopefully you can see we also have vertical asymptote through x equals 0. The graph, as our y values get closer and closer to infinity, as it keeps going up and up, this graph is going to get really close to that y-axis. But just like before, with our horizontal asymptote, the graph is never actually going to equal 0. So here we have a vertical asymptote. It's written as the equation of a vertical line. So you have to write x equals, and in this case, x equals 0. Next thing, do we have any x-intercepts or y-intercepts? Well, let's look at x-intercepts first. Well, we have a horizontal asymptote that's going through our x-axis. So no, the graph is never going to touch the x-axis. What about y-intercepts? Will the graph ever intersect that y-axis? Well, we have a vertical asymptote through the y-axis, which means the graph will never touch the y-axis, so there are no y-intercepts. Okay, well, it was easy to find the asymptotes and intercepts if we were looking at the graph. However, how could we determine those same things if we were just looking at the equation if we're looking only at the equation, okay? Well, there are certain steps that we can always follow that can help us find these things. What I want you to do is pause the video and copy this table down. So you need 6 columns, and we'll start off with 2 rows. Go ahead and pause the video now. Okay, we're back. The first thing we're going to look at are our vertical asymptotes. To find the vertical asymptote, the rule is that we are going to set the denominator equal to 0, and we're going to solve for x. Remember, a vertical asymptote is the equation of a straight line, which means that we're going to write this equation as x equals and then whatever the number is. Recall, for f of x equals 1 over x, our parent rational function, here, if we set the denominator equal to 0, that's how we figured out what our vertical asymptote was. But at that time, we were just using the graph. Okay. How do we find horizontal asymptotes? Well, the horizontal asymptote is dependent on 2 things: the degree of the numerator and the degree of the denominator. Okay. And if you're wondering what degree means, the degree is the exponent of the highest term. So num degree here means, I'm going to call that little n in just a minute, that's the degree of the numerator. So what is the exponent of the highest term in the numerator? Den degree is, I'm going to call it little d, is the degree of the denominator. Okay, so n is the degree of the numerator, and d is the degree of the denominator. There's 3 cases that we find here. The first case is this example here. The degree of the top of my numerator is 2, and the degree of my denominator is 1. So n equals 2 and d equals 1. In this case, the degree of the numerator is larger than the degree of the denominator. So I like to call this top-heavy. If our function is top-heavy, there will be no horizontal asymptote. If our equation is bottom-heavy, like the next example, okay, so here the degree of the numerator is the exponent here, which is 1, and the degree of the bottom is 4. Okay, this is the term with the highest exponent. So my degree of the numerator would be 1, degree of the denominator is 4. So this is an example of a bottom-heavy rational function. In this case, our horizontal asymptote is y equals 0. Finally, what if we have a case like this? Here our degree of the top and bottom is 2 and 2. Is 2 and 2, and I have a typo here. So n equals 2 and d equals 2. In this case, if n equals d, if the degrees are the same in the top and the bottom, then our horizontal asymptote is going to be y equals whatever their coefficients are divided by each other. So the coefficients here of this, of the terms with the highest exponent, are 4 and 2. Well, y equals 4 divided by 2 is y equals 2. So our horizontal asymptote in that case is y equals 2. Feel free to pause the video if you need to copy. Next, x-intercepts. Where does the graph cross the x-axis? Well, if it crosses the x-axis, that means that our y equals 0. Okay? So to find our x-intercept, we are going to set the numerator, the top, equal to 0 and solve for x. We do that because setting the numerator equal to 0 will make our y equal to 0. Y-intercept, wherever you see an x, you're going to substitute in a 0. So substitute 0 in for x, wherever you see an x, and then we're going to solve for y. Go ahead and pause the video, copy what you need to, and let's look at some examples. Next, go ahead and copy these examples beneath the rules that you previously copied. Okay, We're going to do example 1 together, and then you're going to try examples 2 and 3 on your own. Example 1, here's our rational function. I know it's a rational function because I have a ratio of 2 polynomial functions. The degree, let's figure out our horizontal asymptotes first. The degree of the top and the bottom is going to help me find my horizontal asymptotes, correct? No? Okay, so the degree of my numerator is 2, and the degree of my denominator is 1. So in this example, we have a top-heavy case. Okay, now look back at your notes. If we have top-heavy, what does that mean about our horizontal asymptote? It means that we don't have any. Vertical asymptote. To find vertical asymptote, I set the denominator equal to 0 and solve. My denominator is x minus 2. If I set it equal to 0, I get the vertical line, x equals 2. X-intercept. How do I find that? X-intercept, I'm going to set the numerator equal to 0. If I set the numerator equal to 0, 3x squared equals 0, what can I plug in for x to get 0? Hopefully you're saying 0. X equals 0. The graph will cross the y-axis, the x-axis at x equals 0. And finally, how did we find the y-intercept? The y-intercept. I'm going to take this original function. Wherever I see an x, I'm going to put a 0. Okay, and I also copied f of x as y. So f of x, I wrote as y. Wherever I see an x, I'm going to put a 0. Okay, let's simplify this. 3 times 0 squared is 0, times 3 is 0, over negative 2. Anything divided by, if we have 0 divided by anything, it's 0. So we have a y-intercept at y equals 0. Okay, so there we did it. We found the asymptotes and the x-intercepts given an equation. Now what I want you to do somewhere next to this problem is take out your calculator and graph number 1 using your calculator. Okay, pause the video, do that now. Okay, we're back. Here is the equation that you should have found on your calculator. Now, when you are typing this into your calculator, you need to make sure that you put parentheses around that x minus 2. Okay, so later when you're graphing numbers 2 and 3, that's going to have parentheses. This is going to have parentheses around it. Okay, be very careful with your parentheses when graphing these on your calculator. And we're going to worry about graphing rational functions later. Right now, I just want you to be able to find asymptotes and intercepts. Looking at this graph, we see that we have an x and y intercept at 0. Okay, so that confirms what we found before here. We also see that we have no horizontal asymptote. There's no part of this graph that seems to get really close to but doesn't touch. Okay, however, at x equals 2, we have a vertical asymptote. We see that the graph appears to approach x equals 2, this vertical line, but not actually ever touch it. What I want you to do now is copy examples 2 and 3 down. Okay, here's numbers 2 and 3, and I want you to fill in the rest of the table like we did above. Go ahead and pause the video and then unpause it when you're ready to check your answers. Okay, we're back. Let's check our answers. Okay, number 2, our degree of the top and the bottom were the same, which means that our horizontal asymptote are the coefficients, 3 over 1. Vertical asymptote of x equals 0 by setting the denominator equal to 0, and you can find the x and y intercepts. On number 3, please note that you must have simplified the denominator on number 3. If you simplify that, what multiplies to 5 and adds to negative 6, well, that's x minus 1 times x minus 5, and once you simplify it, you can easily find your vertical asymptotes. Go ahead and pause the video if you need to copy the answers. Go back and also graph each of these functions and make sure you know how to graph them on your calculator.